Welcome to Calbeckistan, the place anybody can learn math. I'm Mr. Calbeck. Today we're going to be doing our easy mode lesson on the distance formula. I've written the distance formula up here, and this is a scary looking formula, and it's really easy to mess up. Lots of you out there struggle with this, particularly anybody that has problems with negatives. Notice the subtraction in here. It's really, really easy to mess it up. I'm going to show you that today this is way easier than you thought it was, and it's actually more familiar than you thought it was as well. So let's jump in, and we're going to get an example or two, and I think by the end of this, it's going to be easy. So I've got an example here. We've got a couple of points, and I've kept the distance formula up here. I get a lot of questions. What is this little x2 thing? And a couple quick things. When you're looking at the formula, this is not an exponent. It's called a subscript, and all it means is the second x. This means the first x. So what we're talking about here is the x coordinate of your points. The y2 and the y1 is exactly the same idea. The y2 is, the y2 here is the second y point. The y1 is the first y point. So that's these guys here. So a question I often get is, okay, which one's the second x point and which one's the first x point? And that's one of the reasons this formula gets difficult. It actually doesn't matter which one you choose, so long as you don't mix and match. The x2s should go with the y2s, and the x1s should go with the y1s. So if you do insist on using the formula, I'd recommend that you make sure that you keep them straight, and I'll sometimes even just write this down. So I'll say, okay, that's x2, that's y2, x1, y1. Notice the numbers are the same in each one. Don't mix and match those. Okay, and you can plug these into the formula. You can actually program your graphing calculators to do it for you, which is kind of fun if you ever get good at programming calculators. However, there's a way faster way to do this. And I want to actually just graph these and see if we can figure out what this is saying. So let's graph this. This is 1, -2. It's going to be right there. And then 4, +2. So there's your point. So what I'm trying to figure out with this, I want to know the distance of that line right there. The distance of that line, that's what I'm trying to figure out. But here, I just want to show you what this formula is actually doing. And once you figure out what it's doing, you realize you've already seen this formula lots of times in other places. This is measuring the distance between the two x points. It's saying how far is it between x2 and x1. And we can actually draw that in on our diagram here. Here's x2. It's saying how far is it to x1? How far is this? y2 minus y1 is saying the exact same thing with the y coordinates. What's the distance between the two y coordinates? And we can draw that one in. Some of you may be noticing here that we've actually got a triangle that we built, a right triangle to be specific, since we're looking at the x and y coordinates. And suddenly what you notice is, wait a minute, I actually know how to find this part of the triangle. The long side of the triangle is called the hypotenuse, and you already know a formula to find the long side of a right triangle, the Pythagorean theorem. If you don't know it, it's a squared plus b squared equals c squared. All that says is I find the length of the first one and square it. Find the length of the other side and square it. And that equals the length of the third side squared. So let's see if we can figure this out. The length of this right here from +1 to 4 is just 3 units long. The length from here, -2 to +2, that's 4 units long. do you think you could find the length of the hypotenuse? Now you can use the equation if you want to. We can plug these numbers in, and we can do it the hard way. Put x2 in, x1 in, and we can subtract and square it, or we can just draw a diagram and do the Pythagorean theorem. Let's see which one looks easier to you. I'll speed this up so you don't have to watch it. Okay, 1 minus 4 squared plus squared. That's minus 3 squared. Negative minus another negative, sorry, that one's that's 2 plus 2 squared, and that's 9 plus 4 squared. That's 9 plus 16 equals just all squared. That's 25 squared. And that's 5. Okay. Whew, that's tough. Or we can go ahead and take a look at the graphed version. I can do 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. Notice here, I got the exact same thing. That's 25 equals c squared. How do you get c by itself? Take the square root, and you get 5. And that's all you have to do. You don't need to do a big, horrible distance formula. You just need the Pythagorean theorem. Let's do one more example, and I'll show you just how quick and easy this is. All right, now if you were to get this problem and you were asked to find the distance, or maybe you were trying to compare the length of another segment, see if they were the same, you would probably be asked to use the distance formula. Or we can just graph this. Negative 2, 1, that's right here. Negative 3, 5, that's up here. So I want that segment, I want that segment right there. I want to know the distance. Now, for me, I just want to do the Pythagorean theorem on it. How far did I go from negative 2 to negative 3? How far is that distance? It's 1. How about from 1 to 5 on the y-axis? That's 4. I'm just going to do a squared plus b squared equals c squared. 1 squared plus 4 squared equals c squared. 1 plus 16 equals c squared. And then if I want to get c by itself, I just take the square root. Square root of 17. You can plug that in your calculator. It's an irrational number. It's about 16.1 though. You can go ahead and plug that in. And that's all, it's about 4.1, apologize. And that's all you have to do. Now here's the crazy thing, you don't even really need a nice piece of graph paper to do this. You can do this with even just the most simple of graphs. All you need to be able to do is count the distance between the 2 points numerically. All right, so here's my last example. I'm not gonna do it on nice graph paper. I'm gonna draw a quick set of axes, and we're just gonna do it quick and dirty, easy mode. Negative 8, 14, I don't know exactly where that is, but I know it's over here because it's negative 8 and 14. So I'm just going to put a point up here for that one. Negative 2, 10, it's a little bit lower and closer to the axis. So I'm going to put this one instead of 8, it's like 2. Again, I'm not even measuring. I'm just doing just a really quick and dirty sketch here. 2, 10, something like that. And there we go. And I might even label these if I'm really getting detailed, but you don't even have to do that if you don't want to. I've got my labels. Now let's just see how far I go. What's the distance between negative 2 and negative 8? That's 6. How about 10 and 14? That's 4. That's all you need. Now you can find your hypotenuse. Just look for those distances. And that's all you need to do. If you're really clever, you can just say, how far do I go from negative 8 to negative 2? That's 6. 14 and 10, that's a distance of 4. You know that distance is always positive, so you don't even have to worry about negatives or positives or anything like that. You don't have to worry if that's a negative 6 or a positive 6. We're just talking about distance on the number line. So that's 6 units, 4 units, and we can plug that in. 6 squared plus 4 squared equals c squared. No distance formula required, just a quick sketch and a little thinking. 6 squared is 36, 4 squared is 16. And we're left here with 52 equals c squared. And you got about 7.2. and you're done. Pretty great. Love easy mode. I would much prefer to do the Pythagorean theorem than the distance formula every time. If you are in calculus watching this, there are some advantages to actually knowing the formula, but if you're in any class below calculus, just use the Pythagorean theorem every time. You're going to be in great shape. This is Calbeck, and this has been an easy mode video.